Good morning students, welcome back to physics class. In the previous video we have seen acceleration. Hope you have gone through the video and understood what is acceleration, right? So acceleration is nothing but rate of change of velocity. So in today's class we are going to see acceleration due to gravity. So what is this acceleration due to gravity? Let's see that. We have learned that when a ball or a stone is dropped from a height, it falls down due to the Earth's gravitational force. It has been observed that the velocity of a ball goes on increasing as it falls through the air. Okay, this shows that the ball has acceleration. Since this acceleration is caused by Earth's gravity, it is known as acceleration due to gravity. So it is represented by the symbol G and its value is 9.8 meter per second square. So what is the value of acceleration due to gravity? It is 9.8 meter per second square. Earlier it was thought that a lighter bodies fall down slowly while the heavier bodies falls rapidly. For example, you can take a metal coin and a feather. So which will reach the ground fast? It is the metal coin, and then the feather will reach the ground. But it was Galileo who has proved from his experiment conducted from the Leaning Tower of Pisa that objects of different masses and size, when dropped simultaneously from the same height, it will reach the ground simultaneously. That means at the same time. That is, when an object is dropped from a height, it experiences uniform acceleration by the gravitational pull of the earth, and this acceleration does not depend on the mass of the body. So acceleration due to gravity is represented by the letter G, and the value of G is 9.8 meter per second square for all the objects irrespective of their masses. Next, we will see the time period of simple pendulum. So what is the time period of simple pendulum? Is the time taken by it to complete one oscillation, right? So we know that the time period of a simple pendulum is directly proportional to the square root of its length. So we can write time period is directly proportional to the square root of its length, and time period is also found to be inversely proportional to the square root of the acceleration due to gravity of a place. So we can write time period is inversely proportional to the square root of the acceleration. So 1 divided by square root of acceleration. Acceleration due to gravity is represented by the small letter G. Okay. Next, combining the two equations, you get time period is directly proportional to the square root of length divided by acceleration due to gravity. So here the constant of proportionality is 2 pi. Thus the time period of a simple pendulum is given by the expression. So you know that the constant proportionality is equals to 2 pi. So you can remove the constant proportionality symbol and then you can substitute 2 pi. So time period is equal to 2 pi square root of length of the pendulum divided by acceleration due to gravity. Okay. So next we'll see seconds pendulum. So what is a seconds pendulum? A simple pendulum that has a time period of 2 seconds is called the seconds pendulum. So what is a seconds pendulum? A simple pendulum that has a time period of 2 seconds is called the seconds pendulum. So let us find out what the length of a simple pendulum should be such that its time period is 2 seconds. Okay. So in equation 10, that is, you have the equation 10, t is equals to 2 pi square root of length of the simple pendulum divided by acceleration due to gravity. In that, substituting the time of 2 seconds, that is t is equals to 2 seconds, and you know the acceleration due to gravity is equals to 9.8 meter per second square. So substitute in that equation, what you get? In the place of t you are going to substitute 2 seconds is equals to 2 pi square root of length of the pendulum. So you have to find out, keep it as it is, divide by 9.8. So now you square both the sides. We get, so squaring on LHS side and RHS side. So you get 2 to the power 2. So that is 4 secant square is equals to, here also the same, you are going to square it, right? So 4 pi square into, so when you are squaring it, the square root and the square will get cancelled, so you get length of the simple pendulum divided by 9.8. so you want to find out the length of the pendulum, so keep it in one side, so send the 9.8 to the other side. This 4 and 4 will get cancelled, so you get length of the pendulum is equals to 9.8 meter divided by pi square. So you know that what is the value of pi, that is 3.14. so pi square means 3.14 into 3.14. so you get length of the pendulum as 99.4 meter. Thus the length of a secant's pendulum is 99.4 meters. Okay. So next we'll try to solve one problem. So a bus starts from a rest and then moves with a constant acceleration of 2 meter per second square. So you have to calculate its time of travel if its final velocity is 20 meter per second. Okay, so when you want to solve the problem, what you have to do? The first thing, you have to write the given, right? So what is given? The acceleration is given, that is 2 meter per second square, and a bus starts from rest. That means the initial velocity will be 0 and the final velocity is given 20 meter per second. So you have to find out the time of travel, t. So you know the formula to find the acceleration, that is change in velocity divided by time taken. Change in velocity is nothing but final velocity minus the initial velocity divided by time taken. So using this formula you can find out what is the time of travel. So send this time to the other side. This is in the denominator. So here it will be multiplication. The division becomes multiplication. So a into t is equals to b minus u. So since you want to find out the time of travel, so you send this acceleration to the other side, that is b minus u divided by a. So b is given, what is final velocity, that is 20, minus initial velocity is 0, divided by time acceleration is 2. So the time of travel will be 2 ones are 2 tens are, so 10 seconds. So what is the time of travel? It is 10 seconds.